Hello, I'm Roman, and welcome back to the series of the videos Neural Networks from Scratch in Golang, where we're using this book called Neural Networks from Scratch in Python, but we write in everything with the Golang. Turns out I messed with the Discord invite. Well, I didn't know that it could be expired, so I created a new link and posted it everywhere so you can join if you wasn't able due to the expiration time. So right now it's unlimited and it will be always the same. So in the previous chapter, I started to work on in the previous episodes, I started to work on the chapter called Real Dataset. There are a bunch of the things I need to implement. So we have the data, we loaded the data, we did the pre-processing already with loading of the images, shuffling, and these things. And right now we go into the batches. That will be the next step. And yeah, it's actually not that far away from ending of the book. It's just 100 of the pages, which, comparing to all of the things that we've passed, looks very few. But this is the topic for today and probably for the next video. I'm not sure how fast I will go with the batches. So let's go. So far we trained, let me check something. Okay. So far we have trained our models, let me do this, by this. I think that should be better for the recording, right? Oops, this and this. We have trained our models by feeding the entire dataset as a single batch through the model. We discussed earlier in the chapter 2 why it's preferred to do more than one sample at a time, but is there a batch size that would be too big? In all of the previous kind of dataset that we have, the number of the samples were considerably small, like 1K top. Our dataset has been small enough for us to get away with the behavior of feeding the entire datasets at once, but real-world datasets can often be terabytes or more in size, which is a non-starter for the majority of computers to process in a single batch. A batch is a slice or a fixed size from the data. When we train with batches, we iterate through the dataset in a chunk or a batch. So for example, each epoch will have kind of internal loop, another one through the batches to go over the whole data set, but in portions. If the data have been shuffled and each batch is large enough and somewhat representative of the dataset, it is a fair assumption that each gradient of each batch should be a good approximation of the direction towards a global minimum. If the batch is too small, the direction of the gradient descent can fluctuate too much from a batch to batch, causing the model to take a long time to train. Common batch sizes range between 32 and 128 samples. You can go smaller if you are having trouble fitting everything into the memory, or larger if you want to train to go faster, but this range is the typical range of batch sizes. You will usually see accuracy and loss improvements by increasing batch size from 2 to 8, from 8 to 32. At some point, however, you will see diminishing results regarding accuracy and loss if you keep increasing the batch size. Additionally, training with large batch sizes will become slow compared to the speed achievable with smaller batch sizes, like our examples earlier with the spiral data requiring 10,000 epochs to train. As is often the case with the neural networks, it's a lot of trial and error with your specific data in the model. For example, imagine we select a batch size of 128 and we opt to do 10 epochs. Also, we actually kind of slicing it. Okay, this means for each epoch, we'll iterate over our data, feeding 128 samples at a time to train our model. Each batch of samples being trained is referred to as a step, we can calculate the number of the steps by dividing the number of the samples by the batch size. Okay, so idea is to go over the whole dataset once. So it's not like we had to reiterate it over and over. Okay. So we have the batch size, steps, shape 0, basically it's a number of the samples. Divided by the batch size. Okay. We use the integer division operator instead of the floating point division operator to return an integer, as the number of the steps can contain a fraction. This is the number of the iterations we'll making per epoch in a loop. If there are some straggler samples left over, we can add them in by simply adding one more step. Okay. Yeah, so we just, taking the leftovers if they are less than the batch size. Why we add this one can be represented in a simple example. 2. Okay. Yeah, this last one is missing. Integer division runs down those. If there are any samples left, we'll add 1 to form the last batch with the remainder. An example of the code leading up to train a model using batches. So we have, for example, the spiral data. We have the number of the epochs and have the batch size. Then we calculate the number of the steps, I guess, for every epoch, right? So, okay, for the epoch in the range of the epochs, for the step in the range of the steps, yes. So we get the slice of data, so from X and from the Y. Basically, I'm taking the step multiplied by the batch size. Oh, there is a range. Step plus 1 to the batch size. Okay. Now we perform the forward pass loss calculation. Okay. We load as a dataset. Oh, so the number of the epochs, for example, will be 10 times to go over the whole dataset, but in steps. We loaded the dataset, defined the number of the epochs and the batch size, then calculated the number of the steps. Next, we have two loops. An outer one with the epochs and the inner one with the steps. During each step in each epoch, we're selecting a slice of the training data. Now that we know how to train the model in the batches, we're interested in training loss and accuracy for each step and each epoch. So far, we have only been calculating loss per fit, but recall that we fitted against the entire dataset all at once. Now we'll be interested in both batch-wise statistic and epoch-wise. For the overall loss and accuracy, we want to calculate a sample-wise average. To do this, we'll accumulate the sum of losses from all epoch batches and counts to calculate the mean value of the end of each epoch. We'll start with the okay, so basically making the full calculate method in a loss class. And when we're going to reset it, we're saving the sum at the count so we can calculate the mean at any point. To do that, we'll add a new method called calculate accumulated inside the loss class. Okay, so this will return this method can also return the regularization loss if include regularization is set to true. The regularization loss doesn't need to be accumulated as it's calculated from the current state of latest parameter at the time it's called. We'll be using this ability during training, but not while evaluating and predicting. We'll discuss this in detail. Okay. Finally, in order to reset the sum and account values to new, we'll add one last method. Reset variables for accumulated loss, making our full common loss class. Okay, so we will need this one, new paths. We will want to implement the same thing for the accuracy. Here we will have added settings, setting the accumulated sum and constant properties in the calculate method for each epoch accuracy and calculated, added a new calculate accumulated, blah. Now we'll modify the train method for our model class. First, we'll add a new parameter called batch size. Okay. We'll default this parameter to none, which means to use the entire dataset as the batch. In this case, training will take one step per epoch. Okay. Okay, let's start with changes to the loss. And I need to remember what I did there. First, I need to check if I have something not committed. No. Okay, let's go to the loss. I think I have the common. Okay, this is this one. So we have the base loss. We have the calculate loss, right? Which is this one, right? So I need to store it in accumulated sum in here. I need to store it inside the loss interface, right? Or inside base loss. Thinking. Well, actually, first I can implement the calculate accumulated. Okay, so I need to take it from somewhere. Then wait. Get the inputs. Oh, I mean, all of the loss function that I have inherit the base loss, right? So I can add the variables here. I can add the functions, and I will need to duplicate the functions like set and get, right? So how it will look like. I will have the sum of losses and the sample. So it's accumulated loss sum, right? And accumulated count int loss 64. So then if I will do this loss base loss, oh no, add accumulated loss sum plot 64 and count. And I'm not sure if the architecture is correct, but let's see. Add accumulated, so loss accumulated count, add count, loss accumulated loss sum plus loss sum, right? Then I need to add accumulated here, right? So I can call it so I have the sample losses, right? Wait. Accumulated sum equals to, what is this? Float 64. I think floats sum, right? Sample losses and accumulated loss sum and accumulated count length of sample losses, right? Okay, then it means I can do this, add accumulated loss sum and this one. And the rest is the same, right? Let's structure it like this. Okay, so I store it, right? Right. It's accumulated. Then I need, so we have this to calculate, then we have to calculate accumulated, which will take the accumulated sum and accumulated count. What it means I have to have the get accumulated loss sum plot 64 get accumulated count in 64, right? And then I can add it here on class by, right? And here on the same, and we return loss, accumulated loss sum, return loss, accumulated count. Right? What it means? It means that I can implement this. Calculate accumulated loss. I don't need predictions and this, so I will take only the loss interface, and then we return data loss. And basically return loss. But I don't need this because I can make it a part of the base loss, because I don't actually need this, and it will be calculate accumulated loss, I think, and it will return loss divided by loss, but we'll need to convert it to float 64, right? That's it. No. Accumulated. Too many. Right. Okay. What I changed in the loss interface? Okay, so basically only it's accumulated. And the next thing. And I will need to do the reset accumulated. I will call it like this, and that will be here. What it means that I have the 1 to 0. No loss. No, okay. Then I have to do the same for the accuracy. So I will need calculate accumulated, add accumulated, and reset. right? Do I have the base accuracy? Optimizations. Optimize. And I guess this one. Yeah, this one is a little bit harder. Okay, let's fix it. This one at accumulated. And so what happened with finding files? And optimized, and then loss at loss sum count. Okay, then what is the next one? Reset accumulated. Okay. Reset accumulated inside loss. Oops, wait. Loss like this. Loss reset accumulated. That's it, right? Okay. Yeah, this one is different because I need to kind of proxy all of these things. Okay, so let's go add accumulated, calculate accumulated, and reset. And we need to do this for common. Okay, with the accuracy, this is different because I don't have the base accuracy. Okay, so probably that's time where I can edit. Just type S base accuracy, right? The accuracy site, no, this. Then what we do in base loss, we need accumulated accuracy count, accumulated accuracy, this one. And accuracy sum, and count. Okay. Accumulate count, and we're doing this and replacing, and this is equals to 0 and 0. And then, okay, accuracy, Oh. Go count. Okay, so I need to add this to this one, right? Add accumulated. Calculate accumulated accuracy. And reset accumulated. Right. What then we need to do? We go in here and we do this. Right? For the accuracy, have this one, and we have the regression. One actually has something. Base accuracy. Okay. Okay. Okay, let's take a look. So there is a base accuracy with a method, and we provide this. Okay, this is fine. Same with the loss. Okay. And yeah, this one. Okay, add accumulated fields for loss and accuracy. So we can go and do the other things. Keyword is setting. Okay, so the next thing is to introduce the batch size. And the question is how I can print every. Can I do this? Batch size int, and then if batch size nil, can I do this? Okay, seems valid, but I should have the errors here. Okay. Epochs batch size print every. So the batch size is nil, right? Then nil, and the same here. No, not here. Here, right? Train. No, I will leave it because I'm still not sure. Okay. will default value if batch size is not set. Okay, so we, I think, define it here. Train step, and it should be 1. Default value if batch size is nil. Okay, and then we need to check if there is a validation, data past set number. So discuss most real life data sets. Okay, I will need to, I think, define them. Validation steps, right? Again, should be 1 anyway. Yeah, so if the batch size is not none, then we need to calculate a couple things. So if batch size doesn't equal to nil, right? What do? We calculate train steps equals to x count equal to training data x dims. Training is count divided by the batch size divided by batch size, right? And if training steps, okay, if training steps multiplied by batch size is less than count, then training steps plus equal to 1, right? Then if there is a validation data, if validation data is not nil, then we change validation steps equals to so we have the count equal to validation data x dims, right? Yes, then we do the same, count divided by the batch size, and I think the same here. It definitely should be moved into another validation. So calculate steps based on data length and batch size, right? Next, starting at the top, we'll modify the loop over epochs to print an epoch number, and then we'll reset the accumulated epoch loss and accuracy value. Then inside of here, we'll add a new loop that will iterate over the steps. Okay. And I think I will stop here because it was the page 556 and the training 556. I will continue with this one in the next video. So then we can go to actually training, and probably I will need more time because I think, well, during this week I will be able to record shorter videos than usual, so maybe 30 minutes top. But yeah, should be back to normality next week. But for now, thank you for watching, and I see you tomorrow. Bye bye.